All right, in this video, we want to find the domain and range of these quadratic functions over here. Now, a lot of different examples because there's going to be three types of questions: questions in standard form, questions in factored form, and questions in vertex form. The methods are going to be slightly different for each of the three, which is why I'm doing so many examples in this video. So typically to find the domain and range of quadratic functions, you generally want to find the vertex because the vertex is going to be used for the range. Domain is basically all real numbers for all regular equations, not for word problems. But let's take a look at this first question over here. This question is in standard form, which means that to find the vertex, I'm going to use the equation x equals to negative b divided by 2a. My b value is -4, so that's negative of -4, which is +4 divided by 2 times. My a value is just +1. If I calculate this, I will get +2. To find the y value of the vertex, I'll just sub in my x as 2 in my original equation. If I sub in 2 in this equation, I'll do it in my calculator. I just get -5. So now I'll do a quick sketch of this situation over here. X value is 2, y value is -5, so that's approximately here. It's a positive quadratic function, which means it opens upwards. So x and y-intercept are not really important. This point is 2 and -5. So now I can do my domain and range based on this diagram. My domain, like I mentioned, is always all real numbers for quadratic functions. My range is y is an element of all real numbers. And since it opens up, y is greater than or equal to -5. Let's take a look at the second question over here. This one is again in standard form, so I'm going to use the exact same equation as this one here. X equals to negative of -12 is +12 divided by 2 times a, which is -3. This is just -2. I'll find f of -2 by subbing this in to the equation there. So -3 times -2 square minus 12 times -2 plus 15 is just 27. And then if I sketch this out, -2 and +27 is up here, and the graph opens down because it's a negative a value. My domain is just x as an element of all real numbers as usual. My range is now y as an element of all real numbers such that y is less than equals to 27. Since it opens downwards, it's going to be less than equal to 27. This third example over here, this is both standard form and vertex form. So technically, if it's vertex form, you can just sketch it out straight away. Looking at this, you should be able to tell that your vertex is just at 0 and -3. Graph opens upwards because it's a positive a value. And then my domain is just x as an element of all real numbers. And my range is y is an element of all real numbers such that y is just greater than or equal to -3. Fourth question here is factored form. There's a couple of different ways to do factored form, but I like to just find the zeros to begin with. So here x equals to +4 and x equals to -2. Then I like to sketch it out. -2 and +4. Positive a value, so the graph opens upwards. Now I need to find the vertex. So I'm going to use my midpoint method to find my vertex. So to find the midpoint, I'm going to add my two x-intercepts and divide by 2. If I do this calculation, I'll just get positive 2 divided by 2, which is positive 1. To find the y value, I'll sub in 1 into that equation over there, which is just negative 18. And then I can just do the domain and range, which is x is an element of all real numbers and y is an element of all real numbers, such that y is greater than or equal to negative 18. It's all about just finding the vertex for all these functions and then doing greater than or equal to if it opens up or less than or equal to if it opens down. I got another 4 examples here for practice. I'll go through these a bit quicker as there's no new concepts over here. So first one over here is already in vertex form. I can tell that my vertex is -3 and -4, and it's a negative a value, which means the graph opens down. So my domain is all real numbers, and my range is all real numbers less than or equal to -4. Next one here, this is both standard and vertex form. So again, I can just sketch it straight away. The vertex is a 0 and positive 4 for this one. Negative a value means it opens down. Domain is all real numbers, and range is all real numbers less than or equal to 4. This one here again is in vertex form. You can tell the vertex straight away is positive 1 and positive 6. And a positive a value, so the graph opens up. Domain is all real numbers, and range is all real numbers greater than or equal to 6. Last one here is in factored form. My zeros are 3 and -7. Sketch it out really quick. -7, +3, positive a value, so it opens upwards. Find the x value of my vertex by adding the two values and dividing by 2. It's just -2. Then I'll do f of -2 to find the y value of the vertex. Which is just -225. So my domain is x is an element of all real numbers, and my range is just y is an element of all real numbers, such that y is greater than or equal to -225. If you made it to the end of this video and you found this content helpful, please hit the like and subscribe button and help me get to 1,000 subscribers so I can get my channel monetized. This is video number 529 without making a single dollar, so I would really, really appreciate if you did that for me. Thank you for watching.